Dear math enthusiasts, today I am going to introduce to you the Einstein tile. What is an Einstein tile? It is a special geometrical shape that you see in my hand. Just observe this keenly. Can you guess what is the length of each side, or what is the angle between any two adjacent sides, whether interior or exterior, or what is the angle sum of all interior angles of this geometrical shape named Einstein tile? Or what is the procedure of drawing this on a piece of paper? What one should do to have this shape other than tracing it? So Einstein tile, as I said, is a special geometrical shape that is drawn or cut out from three regular hexagons when they are drawn adjacent to each other by following certain rules. Einstein tile can be copied and can be filled in together again and again to form a tessellation. What is the meaning of a tessellation? Tessellation is an arrangement where the identical geometrical shapes or non-identical geometrical shapes are connected to each other with no gaps in between them, and they form a beautiful pattern. Pattern is something that we see among numbers or geometrical shapes that follow certain rules. But Einstein tile, though it forms a tessellation, it does not form a pattern. And such pieces, when we connect them to end to form a tessellation, that completely creates an optical illusion. That's the reason this kind of a shape named Einstein tile is of great interest to mathematicians who often study pattern and the correlation between the geometrical shapes. The Einstein tile is otherwise known as the aperiodic monotile. And why is this called an Einstein tile? It is called an Einstein tile because the word Einstein in German literally means a one stone. So this is not a join of 2-3 different geometrical shapes finally, and we get this. The Einstein tile was recently found by one of the tile hobbyists named David Smith of England. If you are a teacher, introduce the Einstein tile to your students. Teach them how this can be drawn or cut out from three regular hexagons when the hexagons tessellate. To introduce this topic, ask your students what it means for a geometrical shape to tessellate, what is the meaning of a pattern, or if you are a student, introduce this in form of hands-on learning mathematics project. In the forward part of this video, you will see how to draw Einstein tile on a piece of paper and take the cutout and form the tessellation. Also, I have represented this topic in form of a math lab activity where I have introduced it as an activity of drawing and studying the Einstein tile. Do watch this video till the end to understand about this new shape called Einstein tile. Now let us see how to prepare an Einstein tile. Einstein tiles, when they are connected to each other, they form a tessellation. But each Einstein tile is found or carved out of another tessellation. You see a tessellation here. Tessellation means regular polygons which are connected to each other with no gaps between them. So here we are seeing some hexagons. Here, three hexagons are connected at a point. We know that hexagon, this interior angle is 120 degrees. So 120 plus 120 plus 120 makes a 360. Once you get a 360, its meaning is this cannot stand as a vertex and this falls flat, and there is no overlapping also. So this is a tessellation made out of regular hexagon. So we need three of such regular hexagons to get one Einstein tile. present the Einstein tile activity to the students. The objective of the activity: to study and cut out the Einstein tile from a piece of paper. So we are going to study about the Einstein tile, and we are going to learn how to cut out or draw the geometrical shape called Einstein tile. The prerequisite knowledge is we should know the meaning of pattern and tessellation. What are the materials required? Materials required are the student's geometry box, chart paper, colored paper, scissor and glue. What is the procedure? First we have to draw a tessellation made up of regular hexagon. So that we have to show in the white paper. So this is a tessellation that is made out of regular hexagon. So this is a regular hexagon, and each regular hexagon is connected to 6 other so that the flat surface is formed. So this is a regular hexagon tessellation. By connecting the opposite vertices and midpoints of opposite sides of this regular hexagon, we will get the hexagon divided into 12 equal parts. I will show this step in the next page as I turn. Then by connecting the outline of these triangular parts as shown in the next figure, that encloses 16 triangles, we get the shape of the Einstein tile. The fourth point in the procedure should be, by cutting out along this line, we get our required Einstein tile. So here in the left side page, each regular hexagon is broken into 12 equal parts. See how it is done? The opposite vertices are connected with straight lines, and the midpoint of opposite sides are also connected. The midpoints of opposite sides, and when we draw like this, we will get this regular hexagon divided into 12 equal parts. See, this is the half of it. 1, 2, 3, 4, 5, 6. So 6 up, 6 down. So 6 congruent triangles each hexagon is divided into. And then to get one Einstein tile, we will require 1, 2, 3 adjacent regular hexagons. So 3 adjacent regular hexagons, as we draw line along along this outline, this figure, this shape is called the Einstein tile. To get one Einstein tile, we need any 3 consecutive regular hexagons. And as we cut out the paper along this line or outline that I have drawn, we will get a single tile which is called the Einstein tile. This is that Einstein tile that I have cut out from this outline. So an Einstein tile looks like this kind of an irregular shape, and when we cut out good number of these, they nicely tessellate with each other, and the final output, when we see when this kind of many pieces are connected and a complete wall is made out of it, that is a beautiful, if all these are triangles, there are 16 triangles, congruent triangles with which a single tile is made. If each of this triangle is made with some kind of finishing or some kind of color, each tile itself is an amazing showpiece. So this is how we can show in one of the white page how the shape of Einstein tile can be cut out. And then some points in observation. So we will observe some beautiful things. The first point in observation that you can discuss with students is these pieces of tile appear as an irregular polygon of 13 sides. So one Einstein tile has 13 sides of different lengths with no specific length, no specific rule for length of side or angle between any two adjacent sides. An Einstein tile connects to each other to form a tessellation without a repeating pattern. That means when you see a tessellation of this kind, there is no common pattern or shape that we can identify So that leads to kind of an illusion that what exactly this piece of wall is made up of. Einstein tile tessellates but doesn't form any pattern, and we can give a conclusion based on these observations. To each Einstein tile, 7 other such tiles can share boundaries or vertex. So when we start tessellating, then to each piece, how many pieces can be accommodated? So when I tried on this, I found 7 such tiles can connect to the sides and at one point to one of the vertex. Second point, in the inference that we can draw out of this activity is, when each tile is taken in different color, a math maze or an optical illusion can be clearly seen. Now, how do you introduce Einstein tile to your math class? You can ask students, what does it mean for a shape to tessellate? You can also ask, do you know about any other shapes that tessellate and do not tessellate? The third question can be, Einstein tile tessellates but doesn't form any pattern. Then at that point we can ask the students about what are the other shapes that form a pattern. That means in a way we are trying to define a pattern. And few more questions, as Einstein tile is also known as an aperiodic monotile. So we can ask here, what do you think that the word aperiodic monotile means? Hope this activity engages the students in the maths hands-on learning kind of activity. Hope you like this video.